Chapter 15 today is going to center on dilution, Chapter 15, Section 5. Dilution is exactly what it sounds like, watering something down. So the process of adding water to a concentrated or stock solution to achieve the molarity desired for a particular solution. Dilution with water does not alter the number of moles of solute present. We're not taking away the number of moles of the solute, we're just putting more liquid water with it. Moles of solute before dilution are the same as the moles of solute after the dilution. So what we're going to do is use the formula M1 V1 equals M2 V2, where M stands for molarity, volume is V, and this is the first set of circumstances where we have a particular molarity of a substance and a certain amount of it. We want to change the molarity of it so we can calculate the volume we need to change it to. Or if it's been watered down to a particular volume, we can then determine the molarity. In order to dilute a solution, you have to transfer a measured amount of the original solution to a flask that has water in it. We add water to the flask to the mark with swirling to make sure that we are dispersing the molecules around as much as possible so they can get as comfortable as possible, and mix by inverting the flask. So in this case, we would dispense the amount of original solution, add water to the volumetric line that we want, and then we can swirl it around and get that settled down to where it is going to be right at the mark. And now we have 500 milliliters of a diluted solution. Let's look at how to do some of these problems involving dilution. So we have a 0.5 molar solution of sodium chloride in an open beaker on the lab bench. Which of the following would decrease the concentration of the salt solution? Would adding water to the solution decrease the concentration of the salt solution? Pouring some of the solution down the sink? Adding more sodium chloride? Letting the solution sit out in the open air for a couple of days? At least two of the above would decrease the concentration of the salt solution. And the only one that logically makes sense is if we're going to decrease the concentration, that means we're going to dilute it, is adding more water to that solution to make it less concentrated. What is the minimum volume of a 2 molar NaOH solution needed to make 150 milliliters of a 0.8 molar NaOH solution? So in order to set up the problem, we just, again, it's kind of like looking at the gas laws and deciding what's what. We have a 2 molar volume of NaOH, so my M1 can be 2 molar. My V1 says, wants to know the minimum volume of this solution needed to make, and I'll let that be my V1, to make 150 milliliters of a 0.8 molar solution. So my molarity 2 is going to be 0.8 moles, and my volume 2, or second situation is 150 milliliters. So all I have to do is solve for x. So I'm going to take 0.8 times 150, and then divide that answer by 2, and the answer is 60 milliliters. And that would be the minimum volume that I would need in order to make this solution. One of the things I want to bring out is that everything's relative. So even though molarity, remember from the previous lectures, is number of moles over liters, it's okay for volume in this case to be in milliliters because the units are going to cancel out. So we don't have to convert milliliters to liters in this instance in order to get to the answer here at 60 milliliters. That's how you set up a dilution problem. At any point that you can be given any or three of any of these variables and solve for the fourth one. So you can have molarity 1, volume 1, and volume 2 given and calculate molarity 2, or any other combination of that. So these problems are easy to work. They are reasoning issues that are simple concepts and ones that shouldn't throw you a curveball. So enjoy doing the easy problems of dilution.